Now, what we need to go over briefly before you have your next project is these plates do move around the world, but they don't move the same way. They don't move in all the same directions. All right? So there are some words that we need to know, and the definitions of these words explain how plates are moving. Okay? So you have this page right here in front of you. You can have a name on that. If you want, that's fine. Just keep track of it, okay? Because you're gonna need to use this, and you're gonna need to use the next thing you're gonna get in order to do your project. That's upcoming. All right, let's get busy here. Okay. So the first word to describe how plates move is this word divergent. Okay, so divergent simply means to pull apart, to pull opposite each other, to pull away from each other. So when the researchers found the Mid-Atlantic Ocean Ridge, that's that thing in the middle of the Atlantic Ocean that they discovered with where seafloor spreading is. That's called the Mid-Atlantic Ocean Ridge. When they discovered that, they discovered a divergent plate boundary. So there were two plates that were touching. They were neighbors, next door neighbors, and they were pulling apart from each other. That space in between where they touch, that's called a boundary. And plates move at those boundaries. Some of them do this. Some plates separate from each other. And that's called divergent. So here's what we write up here. And then I'm going to show you a little icon to draw that will help remind you what divergent means. So up here, where it says divergent, we're going to write divergent is a divergent boundary is where new crust, new ocean or continental crust, new earth crust, okay, is being deposited as two or more, usually it's two or more plates pull away from each other. Okay? New crust is being deposited or being developed as two. So the two plates pull apart, and where they've separated, new magma right from underneath, from the asthenosphere, bubbles up and kind of oozes out and seals that new crack, and now you've got new crust there. So lava comes up, oozy eruption, not very explosive, it's just kind of up and out, and there it is. Cools, hardens, and it becomes new crust. And then later that crust will crack open again, and the plates will slide apart from each other, and you'll get more oozy, slow volcanic eruption that kind of fills that gap, cools, hardens, and becomes new crust. So new crust is being deposited at divergent boundaries as two or more plates pull away. Okay? This is the diverging part, where two plates touch and they go whoop. Okay, not that fast, but they do make that sound. Okay, what do we draw here to help us remember what divergence means? Okay. Well, it's a very simple drawing, okay? And most of these are very simple drawings. The ones down here get a little involved, but this one and this one, easy. Okay? Here's how I draw a divergent boundary. Okay, give yourself like a kind of like a puzzle piece kind of shape there, where you've got one puzzle piece touching another puzzle piece. So this is one plate. Okay, this is plate number one. Here's the other plate. Here's its neighbor, plate number 2. Okay, and you're looking at it from the top down. You're looking at it like you're looking at a map of the world. Okay, you're looking at a globe, all right? And you've got this boundary, this line that separates plate 1 from plate 2. Here's all you need to do. Okay? Divergence means this. That's it. That's all that divergence means. Okay? Now, typically, as these break away from each other, they separate, typically you're going to get volcanic eruptions through here that will erupt and cool and harden and become new crust here. While, and you don't have to draw this part if you don't want to, but what you end up getting is you end up getting areas, corresponding areas on either side of this boundary that are the exact same thickness and the exact same age. So right in here, right on this boundary and closest to it, that's the very newest or the youngest. That's the very newest or very youngest rock, the new crust. That's the youngest. So when the eruptions erupt, they kind of come out both sides like this, and they deposit new crust right here on either side. And over time, they will this cracks open again. So what used to be the youngest moves out to here, and we get new, even younger crust that develops here because volcanoes erupt. This magma cools and hardens and becomes new ocean crust. So as you move to the right or to the left from a diverging boundary, you end up getting rock that is progressively older and older and older and older. It's youngest right here, it's newest right here, and these rocks on either side, equal sides of the boundary, right? They keep getting older and older and older as this plate moves this way and as this plate moves that way. And that's what we saw in the slideshow about seafloor spreading. We saw this map that they built where you saw all the colors, and as the colors moved to the right and left, those rocks got older and older and older. Okay, so this is one way, divergence. This is one way that plates can move. They can move apart from each other. Okay? Now, what's happening under the plate that makes them go apart from each other? Remember this? Remember that? Remember how we had all this oil in here? We had that candle, and what you had was rising oil, and then it would split off into both sides. These would split off because there was more oil at the bottom that wanted to rise too, because it was in contact with the heat. So you had the oil doing this. And you could tell that because we had our spice flakes all up in here. And they were separating and moving away from that central point. These were moving that way. These are moving that way. So the flakes that rested on top of the oil were showing you what the oil was doing. And they are moving because the oil is moving them that way. That's exactly what's happening at a divergent boundary. You have the asthenosphere underneath our crust. The asthenosphere is doing this. and that is causing a gap, a break in our lithosphere. Right? And you've got, so that means as the asthenosphere is moving this way, it's pulling, it's cracking open this crust. Most of the time it's on the ocean floor, but it could happen at continental crust as well. But you've got all this motion of the asthenosphere pulling apart, and that's driving where the plates are going. These plates, here's plate 1, here's plate 2. Okay, there you go. There's your divergence. That's what's happening. This is happening right here, and it looks like that from the top down. That's divergence. Okay, so you've got new crust being built, being deposited, because the asthenosphere is doing that and cracking open that crust and pulling it away. Okay, now, the most common, right, and you'll see this when you do your map that you're going to get. The most common way that plates move actually is not this way. There's several divergent boundaries out there around the world, but it's not the most common. The most common is convergence, to converge. So if divergence is this way, then that means convergence is this way. So when these plates run into each other and keep running into each other and keep running into each other and keep running into each other, and you see what's happening? Okay? So you've got plates that pull apart from each other, but mostly, I'd say 65% of all the boundaries around the world that you'll see, that you'll experience and explore, you're going to find a lot of convergent boundaries, a lot of them. Okay? So what does this mean? Well, a convergent boundary is when two or more plates collide or smash against each other. Okay? When two or more plates collide or smash against each other. That's convergence, a convergent boundary. So if diverging boundaries or plates happen because the asthenosphere is doing this, and the oil in our bread pan was doing that, which showed us divergence, what must the asthenosphere be doing underneath the crust for plates to converge? Well, the oil or the asthenosphere must be doing this, must be coming together and pulling down and grabbing more heat energy to go back up somewhere else in the asthenosphere. Okay? It's like this. We know about this. We know about that. But you know, eventually, just like in the lava lamp and just like in the bread pan, eventually, you know, it's the hottest oil or the hottest asthenosphere that's going up here. And the lithosphere is above it. So it's got nowhere else to go, so it has to separate from itself. But up here, it's furthest away from the very, very hot core. So it's actually cooling down and becoming more dense. And eventually, when this area of asthenosphere is more dense than the asthenosphere around it, it's going to sink. It's going to drop back down to the bottom of the asthenosphere to pick up more heat energy so that it can eventually rise again. Okay? So there's another kind of part to this convection cycle, right? We've kind of focused on this part where it's going up, like the lava lamp. It's going that lava is going up because of the heat down here, right? Well, what happens after a while? It's been up here, it's been far away from the heat source, it's cooling down. Eventually, it becomes more dense than the other asthenosphere next to it, and it will start dropping. So what does that mean? What happens when you've got rising somewhere over here and rising somewhere over there, rising asthenosphere, yeah? But the asthenosphere from these other rising areas somewhere on the world, the asthenosphere is bunching up against itself. Boom. So it's got, the only thing it can do is drop down. Where the asthenosphere does this. Well, that is what's happening under convergent boundaries. You've got a plate over here. You got plate number 2 over here. You got plate 1, you got plate 2, and instead of them separating, they're coming toward each other, and give them enough time, they will start smashing up onto each other and start building up landforms. Eventually, so that's one thing that can happen. There are 2 other things that could happen when they smash into each other. And the thing that determines what they do is all about what type of crust is being smashed into what type of crust. And that's why you've got these 3 right here. You know there's 2 types of crust, oceanic and continental. Okay? Here's what we do. You didn't have to draw that thing. You didn't have to draw this. You didn't have to draw that. That, I just wanted to show you that. This is what you draw. Okay? Now, one of the very first things I ever told you about oceanic and continental crust, there's 2 types of crust, was I told you what they were made of. I also told you that one of them was more dense than the other. Okay? Oceanic crust is more dense than continental crust. It's very important for you to remember because when they smash, one of them is going to win, the other one is going to lose. And it's all about which one is more dense than the other. Okay? So right now you got, let's look at what happens when you got oceanic crust smashing continental crust. Okay. There you go. All right. So you've got oceanic crust right here. And over here is continental. And what you've got is, okay, you got the asthenosphere under here. The asthenosphere is doing this. Okay? It's doing that. That drives the plates into doing that. But when the plates collide, okay, oceanic crust is more dense. So what's going to happen is oceanic crust is going to get pushed down underneath continental. But that forcing right there is actually going to force the continental crust, which is less dense, to bend but buckle upwards. This is called uplift. It's going to buckle the continental crust upward, and you're going to get mountains to be developed and built like right here at the shore. Okay? Or not too far off the shore. The Andes Mountains are a great example of this. Oceanic smashing up against continental. That oceanic crust is being driven back down into the asthenosphere while the continental crust is being buckled upwards to make the Andes Mountains, South America. Okay? Great opportunity here. So you have the oceanic crust is being driven down. That's called subduction. And the continental crust is being buckled, but it's also being uplifted and buckled upward. And you're getting mountain building that way. So there's one result of this. You can get oceanic crust and continental. Oceanic goes down under. Continental crust gets buckled upward. You can have, and a lot of these are there out in the ocean, you can have oceanic to oceanic. And what you're going to find is you're still going to have one plate that might be a little bit more dense than the other. So that one, whichever one is more dense, is going to get subducted. Okay? They're both oceanic. Which means this is all happening underwater. But look how similar this drawing is. Look how similar this drawing is to that one. The same mechanisms are happening. The same thing has taken place. And the asthenosphere is doing the same thing. It's doing this. Okay, it's still doing that. But because all this is happening out in the ocean, we don't call this a mountain, we call that an island. So many islands in the world are made this way. Made this way. You could even get some volcanic activity to break through here, and you could make this volcanic in nature. That could be a volcanic island. Same thing with this. This could be a volcano on dry land because this crust is getting weak from being broken down and buckled. So you've got a asthenosphere that could make its way through and find the cracks, and you could have a volcanic mountain like the ones we typically think of when we think of the word volcano. So you've got oceanic to oceanic crust convergence. What happens when you have continental and continental smashing into each other? Well, what you end up having is you have continental crust that is smashing up against continental crust, and what you tend to get is, while you can get some subduction, some of that energy will go into subduction here. More of that energy actually goes into buckling upward. More of this energy actually goes into buckling upward, and what you end up getting is, you end up getting mountains, like really tall mountain chains. As a matter of fact, the tallest mountains in the world, if you measure it from the base up, is Mount Everest. And Mount Everest is made exactly this way. India, which didn't used to be a part of South America, which didn't used to be a part of Southeast Asia, India, eventually moving off of Australia and Antarctica, finally smashed into Asia. And it's still pushing up into it and creating and buckling and folding upwards those land masses. And that's how Mount Everest was created. So this is continental, and this is continental. So those are the three things that could happen when the asthenosphere is moving this way. What happens depends on what type of crust is being smashed into what type of crust. Okay? Now the last one is very quick. It's very simple. Okay? It's transformed. So you've got plates that can do this, you got plates that can do this, and then you actually have plates that neither one wins or loses. They just kind of slide past each other going opposite directions. That's called transform. So when two or more plates when two or more plates are sliding past horizontally past each other. And usually it's two. Usually it's two plates. And this drawing is very simple. Very, very simple. It's even simpler than this one. Okay? The most famous example of a transform boundary in the world is in the United States. So you've got plate number 1, you got plate number 2 right here, okay? And all they're doing is they're sliding past each other, okay? Nothing is being subducted, nothing is being really buckled upward. One isn't winning or losing. They're just kind of sliding past each other this way. Now, this is very, very tectonically active. Okay? And you get lots of earthquakes because these plates are very bumpy and craggy and they have lots of edges on them. And whenever they're trying to slide past each other, they're getting caught up, they're getting bunched and stopped all the time. All the time. And then they have to finally release that energy, get freed up to start moving, and then they'll get locked up again, and then they've got to jostle free again, and then they move, and then they get caught up on each other, and then they got to break free again. So there's lots and lots of earthquake activity with these types of boundaries, and the most common one, the most famous one in the whole world is the San Andreas Fault in California. That's one of these, and it's very, very seismically active.